Okay, so today we're going to go over test dimensionality and factor analysis. So when we're talking about dimensionality, we're talking about how scores on the psychological test should reflect at least one psychological attribute of your client. So generally, but not always, when you're measuring a physical or psychological attribute of a particular object or your client, pretty much what we got to do is focus on the single attribute of that object or the person. So in speaking about dimensionality, here we have to utilize it for test construction, for our evaluation, how we use it, as well as interpretation. So what we do is we have these three different type of tests that we can utilize as we're constructing questions. The first one would be called an undimensional test, and pretty much this reflects just one psychological dimension that's looking at the specific attribute behind what's being tested. So all the items that might be combined in some way, and it's usually through averaging or summing or counting, would be able to form a composite or total score of that particular attribute. So the second type is called the multidimensional test, and this is with correlated dimensions. Here we're looking at how the items would reflect more than one psychological attribute. With multidimensional tests, here this is with the correlated dimensions, will produce a variety of different scores. Basically, each subtest alone will be considered undimensional, but the questions are going to be theoretically uniform. So with it being multidimensional tests and it's correlated because of the scores to produce that total score would be combined across several subtests. And then there's the third one, multidimensional tests with uncorrelated dimensions. Now in this aspect, this is when there are weak properties that would be in association to the attribute. Thus it leads to being treated as unidimensional. So that's why it's important for us to be able to understand the type of test that's being developed or used when we're doing psychological evaluations, because these tests will have important psychometric properties and differences from one another. And with that understanding, in terms of interpretation, the score of your client should be relevant to the trait that you're attempting to measure. Now, when we develop a test, excuse me, or we try to measure an attribute, we have to address the following type of questions. So there's these three core questions. First one being how many psychological attributes or dimensions are going to be reflected within the test items. Here what we're doing is we're attempting to learn about, say for example, one's intelligence. Then in this case, we must understand how many dimensions of intelligence are going to be required to be able to have a full interpretation of that person's level of intelligence. So if we're looking like, for example, verbal reasoning or visuospatial reasoning, etc., then we realize that we would create a multidimensional construct. This would lead us to being able to decide whether or not there's an association that's significant enough to be able to determine whether a multidimensional construct would be correlated or uncorrelated. So that would include eigenvalues and factors that would involve us to lead to what the third question is talking about. That being, if a test items reflect more than one dimension, then what are those dimensions? Excuse me. And what would they be exactly? Which dimensions are going to represent the attribute that we're trying to measure in the first place? So more or less, the psychological meaning of test dimensions, after we looked at the first two issues which were addressed, that being the number of dimensions reflected in the test items, as well as the association among multiple dimensions, would be the third important dimensionality issue that would be needing to be examined. Specifically saying that the tests, those who would be developing tests, those who are evaluators as well as users have to understand that the psychological meaning of each test dimension in order to use it. If you don't know, for example, why you may ask a person if they're depressed and you use the Beck, and you don't know why you're using it, then what's the purpose of giving it? So, uh, test developers and evaluators would have to conduct research that's going to help to reveal those psychological attributes that's represented by each test dimension. So as we go further, we'll talk, about other ways in which research may be conducted, but this is just to provide you with at least the basics of these statistical procedures, but specifically factor analysis, which is going to often be used as a fundamental tool when we're doing examination of test dimensionality. It helps us to understand the logic. It allows us to talk about the information that we're trying to seek and find, and it helps us to answer those three core questions in test dimensionality. So just to give a quick rundown of the importance, of course, it helps in determining our ability to score effectively, our evaluation and interpretation process of the test scores. It allows us to kind of review and evaluate a number of different dimensions, thinking about the scores separately, whether or not the person would receive the score on the similar tests, would it be about the same? Each score is going to have its own psychometric evaluation. Again, one attribute, we try to do interpretation for one, like unidimension. And then we also need to be able to look at it in terms of what the underlying scores would represent if there's any type of correlations. So let's talk about factor analysis. A statistical procedure often used to evaluate one's test dimensionality. So one way we look at it is whether or not the test item is going to relate to the attribute that we're measuring. Okay. It would be able to allow us to utilize factor analysis in that test developers will be able to use a variety of different statistical procedures to help in the evaluation process for test dimensionality. And although there are several methods to allow us to evaluate the different models as well as questions that will be used in an assessment, like cluster analysis and the multidimensional scaling, a more common method that would be used would be factor analysis. Using factor analysis allows us to be able to answer the three core questions that were mentioned earlier. And with factor analysis, the test developer basically can be mindful of any type of pertinent issues like the scoring potential, the evaluation process, and of course in the use of psychological tests. There are two types of factor analysis that we are going to be looking at, that being the exploratory factor analysis, which is more of the common type that will be used in applications like SPSS or in the SAS. And then generally speaking, this type is what you might want to utilize when first constructing a test or design. And then there's the confirmatory factor analysis. Now with the confirmatory factor analysis, this is often a more restricted type of factor analysis, or it's also known as a structural factor analysis, in terms of it's a more of the deductive type mode to test hypotheses regarding any type of unmeasured sources or variability that's responsible for the commonality among a set of different scores. And it's a good way to be able to analyze those attributes, particularly within social sciences, which is us. So, okay, so when we're using an exploratory factor analysis, pretty much we're attempting to reduce data to a smaller set of summary variables in terms of allowing us to discover those underlying, underlining theoretical structures of the attribute that we're trying to measure. So the main use of it is to identify whether there is a relationship to one variable of the variable to our client. So when we're looking at a personality within the psychological assessment, often we can kind of see where one attribute can be seen in several different ways. One word might provide many personality attributes. So using an exploratory factor analysis, it helps us to be able to narrow down those variables and be able to focus on specific results that we will be seeking. When we use a formula or try to formulate a matrix, it helps us to guide us in the assessment and evaluation process. Now, so this is a correlation matrix of those personality attributes that was on the previous slide. Um, and more or less what this table allows us to see is how the correlation coefficients would be between variables. Each cell in the table demonstrates the correlation between two variables, and it allows us to summarize it, take that data and to be able to input it into a more advanced analysis as well as a diagnostic or advanced analyses. So we can take a look and see whether any of those particular attributes are relative to one another. And here we can see talkative and assertive, as well as outgoing, they're significant to one another. But when you come down to creative and imaginative and intellectual, then you don't see it as much. And the list goes on. So being able to explore those, it kind of helps us decide now, out of those six, which ones do we really want to be looking at, taking a look at in terms of our questions that we might have. So just going back and looking, if you was to take those personality attributes, you would actually have to ask yourself these particular type of questions. How many personality attributes would be reflected within those six adjectives? And are they truly attributes that we want to be measuring? Are they really truly correlating with each other? When we're looking at it in real time, this is something that's really hard for us to pick up on. And by doing an exploratory factor analysis, it allows us to break it down so that we can actually see if there's any true significance in us even taking a look at it. So think about when you're doing your research. You come up with your hypotheses, and then you wind up with so many variables on top of that. With exploratory factor analysis, it allows you to take a look at each and every one of them and see whether or not it's relevant to what you're trying to get for your answer. And the less significant, it means more than likely it's something that's not going to relate to the attribute that you are measuring. So therefore, you don't have to even take a look at it anymore. It's one less thing to be having to worry about on your list. So how does it work anyway? As we mentioned, we're looking at correlations. And it's based on those that there's going to be several steps that we take, which I'm going to talk about in a minute. But it's a back and forth process. You're going to look at a variable. Let's say, for example, we looked at creativity and talking, and we saw that there really wasn't no big significance between the two. But what if we flipped that script in which the creativity was about writing a poem? Now I threw another variable in there. But it's a back and forth process. As you're trying to reduce the number, you're going to have to always double check to make sure that depending on the situation, it didn't increase as far as significance. Okay, so first and foremost, I'm sorry you're only getting just the audio at this point. However, it's not a pretty picture. My eye has become inflamed, so I'm continuing on, but I'm just going to use audio. So again, my apologies. But We left off, we were talking about, and I'm talking about now, uh, how exploratory factor analysis works. So this lovely diagram here gives you kind of a breakdown of pretty much of what you would do when you're utilizing exploratory factor analysis. So the first step is we have to choose an extraction method. So when we're talking about an extraction method, we're pretty much saying a specific statistical technique that we would use, and there are several different options that we can choose from. We might decide to use the principal access factoring method, uh, which would give you the maximum level of for factor analysis. But then there's also the principal components analysis that gives you a high probability as far as looking at the correlations. In both the PAF and the PCA, I'm going to break that down to just the initials. They're really common choices that's used with exploratory factor analysis. But when we're using the PCA, it's really not considered to be factor analysis. It's more like looking at the same thing, but considered to be a way of just pulling together those popular type of software packages like SPSS that utilizes factor analysis procedures. So although you might get some information from the PAF, more times than not, it's going to really come from the PCA. Um, but a lot of people still consider PAF over the PCA. So that's where the extraction part comes into play. So now when we're talking about once we get to the point of the extraction and we choose a method, now we're going to go and look at to try to identify the factors that's involved. So when identifying those different type of factors that we're going to extract, that second step is going to be taking the number of factors that's within our set of items and then being able to use the statistical type of software like SPSS, pull those items or factors out. Um, the bad thing about it though is we really don't have a single simple rule that would allow us to be able to make these specific identifications. Rather, we kind of rely more on rough guidelines, and it's more subjective than anything else. So to kind of address the situation about how many factors or the number of factors we'll be extracting or working with, most test developers, as well as users, they go into utilizing eigenvalues, eigenvalues. I always have fun with that word. But they utilize this because it provides a total variance explanation. And there's 6 eigenvalues that will provide you with a total that will be provided within this slide under those different headings. So looking at the high-tech definitions of eigenvalues, basically, bottom line is it's just basically how we would use them and not what they are specifically. There's many different ways in which we can take the information, such as parallel analysis. However, we'll just look at these 3 ways that are more commonly used for integrating the populous type of software packages like SPSS. So this flow chart, though, like I said, gives you a kind of understanding that once you do the extraction of the different factors, you would want to have to determine whether or not it's going to present with just one factor. Then we know it's plain and simple. We'll just have the unidimensional scale to work from. But if it's multiple factors, then there's a couple of things we have to consider. Whether or not it's going to be multi-dimensional that's correlated or uncorrelated. So most times this is an ambiguous structure in the sense of we have to pull different information from these different factors. And again, it's ambiguous because it's a judgment call on your part of what you find to be an important factor to the attribute that you're trying to work with. So looking at those steps, I know it can be confusing. I do recommend that you go over it again in the textbook. That provides similar explanations, but more or less, when you're talking about the exploratory factor analysis, you're exploring basically those factoral structures or a set of measured variables without trying to impose any type of uh, preconceived type of information to the outcomes that's usually going to be toward underlying factors of a set of variables. And pretty much what the approach will allow is that give you a way to describe and identify those constructs. So when we're talking about this approach, you really want to just basically use scale development if at all possible, because when you're developing a scale to be able to measure things like depression, for example, or suicide ideations, then factor analysis would be that recommended type of method. So again, just breaking down those steps, you're going to have to choose your extraction method, be that PCA, for example. You're going to have to then look at ways of identifying the number of factors that's involved once you've extracted them. You'll have to look at one factor at a time and decide whether or not if there's one, then you know it's going to be unidimensionally uh, driven, or if there's going to be a multi-dimension in sense with uncorrelated or correlated information.